Hello everybody. In this video, I will be teaching you how to do FOIL and polynomial expansion. If you have no idea about the words I just said, don't worry. I'm going to be going over these in the video comprehensively. Now on the screen, I have a little sneak peek of what we're going to be doing in this video, and mostly it's going to be multiplying two binomials. A binomial is basically what we have in parentheses. It's a term with two things added to each other. For example, we have a plus b, and we also have c plus d. Now, the question we have is, what is this going to come out to be? For example, if you have 2 times 3, right? If we're multiplying two things together, if we have 2 times 3, well, we can't just leave it as 2 times 3. We need to actually simplify it. And obviously the answer is 6, but in this case, we have variables, and variables make our answers different. So I'm going to be going over that in this video. Now, one of the first things that you should understand, and whether you learned it or not, you should still be reviewing it, is the distributive property. Now you'll see in a moment that FOIL is just an extension of the distributive property twice. That's a little bit of a spoiler, but we're going to state it again. If we multiply a by the quantity b plus c, that equals a times b plus a times c. So the reason why it's called the distributive property is because we're essentially distributing a to b, and then we're distributing a to c. Now, to give you an example for convenience sake, is, for example, if we have 4 times x plus 1, we're going to distribute the 4. We're going to multiply 4 by x, 4 times x. When I write multiplies, I'm going to use a dot so that we don't confuse it with x. And we're going to multiply 4 times positive 1, which gives us, as a final answer, 4x plus 4. Note that this is not equal to 4x plus 1. We are not just multiplying 4 by x in the front. We have to distribute the 4 so that it works. And this is a common principle that we're going to be using in all of polynomial expansion, so make sure you understand this. Now I'm going to be going over some general definitions. So first, what even is expansion? Well, expansion is just the process of multiplying a lot of things together. You've seen this everywhere. Besides having x and y in your life, you've seen probably 2 times 3 times 6. This is something we have to expand out or multiply together to get our answer. Now this is obviously 36, but I will not be going over the general arithmetic in this video, but rather the algorithm to do it with variables. Now, we're going to be talking about polynomials. And it's important to get this definition straight because a lot of people have, mistakes or some kind of misconception about it. A polynomial is an expression that includes the sum of constants, coefficients, and or variables raised to a positive integer power. Now, when I say sum, I mean something like x plus 2. But also, it could just be one term. It doesn't need to be a sum necessarily. And note that I used and or because it just needs to be at least one of these things to be a polynomial. What I mean is that a polynomial could just be a constant. It could just be a variable. And that variable has to be raised to a positive integer power. For example, 1, 2, 3, 4, or sometimes you could do 0, but that's technically 1 because x to the 0 is just 1. Now, for example, I'm going to give you, for example, if they ask you, 1, is that a polynomial? Well, surprisingly, yes, because it's a constant. And remember, to be a polynomial, you just have to be at least one of these things. Now, for example, x plus 2, that is a polynomial. Why? Because we have a variable and we have a constant. So yes, this qualifies. Now, what if I say probably 2x squared minus 3x plus 4? And you're probably like, whoa, that's a lot of things. Well, this is technically a sum of many different things. We have 2x squared, and then technically we're adding negative 3x, and then we're adding 4. And we have coefficients, and we have a constant, and we have variables raised to a positive power. So yes, this is a polynomial. Now, there are some interesting things where it would not qualify. For example, 1 over x. Generally, this is equal to x to the negative 1. If you know that, that's great. If you didn't, now you know. And negative 1 is not a positive integer. So, it's not a polynomial. Now, what if we have something like 3 to the x? Well, this is where it gets kind of ambiguous, and I will say this. You cannot have a variable in the power, in the exponent. This makes it not a polynomial. So, that is not a polynomial. Now, this is what you've been waiting for. What does FOIL mean? Now, when I say FOIL, I don't mean the thing that you use to pack your lunch with. It's a strategy that helps people to do math. And it's an acronym which means first, outer, inner, last. And what this does is it tells you the order in which you multiply terms when you're multiplying two binomials. Note that this only works when you have two binomials. It gets a little wonkier when we have maybe a trinomial, but I will be teaching you that later. But this is good to know. So when we're multiplying two binomials, for example, a plus b times c plus d, first we're going to multiply the first terms in each binomial. In the first term, in the first is a, in the first term, in the second is c. So we just multiply these together. So you get a times c plus, and then we're going to take the outer ones. We're going to take the one on the left side, which is a, and we're going to take the one on the right side, the rightermost side, which is d. And so we're doing a times d, which gives us ad. Now we're going to do inner. We're going to do the ones that are squished together in the middle. I'm going to be using yellow for that. So we're multiplying b times c. And then, lastly, we're going to be multiplying the outer term, which is just b times d. Okay. Now, if you don't understand much of what I said, I have a small picture here that may or may not help you understand this a bit better. So, we can think about this like giving pets, treats, or giving kids candy. We're distributing the candy / treats to the things inside the sum. So for example, let's name this stick man over here. Let's call him, I don't know, Alvin. And Alvin, he has a job. He has to basically give the dog and the cat each a treat. So this is basically kind of like a metaphor for multiplying two things together. He's gonna first give it to the dog, then he's gonna first give it to the cat after. Now, things get a bit more complicated when we just add another person, another candy giver. For example, let's say, his friend, Patricia. Patricia wants to also give the dog and cat candy. And so, we're gonna do a thing where Alvin gives each of the pet a candy, and then Patricia gives each of the pet a candy. And now, why am I even doing this? Because this is the general principle of how we're going to be imagining things when we don't have FOIL to use. For example, if we had a trinomial, like I said, things are going to be different. And this will all start to make sense once I give you some practice problems. Okay, so our first practice problem is x plus 2 times x plus 4. Now, all you need to do is just apply FOIL because we see two binomials, and thus we can use FOIL. So first, we're going to take the first x times x, x times x, and then sum that with outer x times 4, and keep adding it, and then inner 2 times x. And then finally we have last 2 times 4 plus 2 times 4. Now, obviously, x times x, that's just x squared. And then we can just rewrite this in the algebra you probably learned in school. And obviously, oh, sorry, this is a 2, not a 6. Apologies. And 2 times 4 is just 8. And of course, we can combine like terms because we have x and x here. Just add the coefficients. So our final answer is x squared plus 6x plus 8. That's it. That's our answer.